econometric model. Saya memang tak cukup nafas sebab sebab hidung tersumbat. Okay, the second subtopic is estimating a simple regression uh, model. Okay, estimating a simple regression model. But it's actually, the method should, okay, sorry. I think the subtopic should be estimating econometric model, but later lah kita tengok balik. But it's a simple linear regression because of you have one independent variable with the one dependent variable lah. Okay, so that one is clear. Okay, why we have simple because of you have only one independent variable. Okay. And then we have the elasticity. It is for the linear model. Okay, elasticity here means that we measure the responsive, okay, of the dependent variable towards the independent variable. Okay, kita panggil the dependentity lah, okay, of the dependent variable to the independent variable. But based on the econometric, we call it as the term that we use is elasticity. But it's actually we measure how dependent variable to the independent variable. Okay, and then we have the hypothesis testing. So I have go through the hypothesis testing here. Okay, so it will be two purpose. Okay, why we have this hypothesis testing. Okay, the first one is for significance of the model, if I'm not mistaken, and the second one if we have like we have kita panggil apa it's not a target, we have the for the rational. Okay, because we know that for the simple linear regression here, the hypothesis that we have is for the slope beta 1. Okay, so the hypothesis that we have is for the beta 1. Okay, but for the econometric here, it will be two purpose of the hypothesis. The first one, beta 1 equate to the 0. And the second one, beta 1 equate to certain number of the beta node here. Okay, we call it as a beta node lah. Okay, so kita ada target value. Kita nak check. Okay, whether the slope increase based on that or not. Okay. Sorry. Okay. And then we have for the prediction and goodness of fit lah. So goodness of fit usually kita nak tengok how significant the model that we have. Okay. Prediction, because of we have the model that we can use that model for the prediction lah. Okay. Sorry cannot. Okay, so overview of the economy and econometric models. Okay, so economic model, okay, more interested in study relationship between the variables to describe the average behavior of the economy and systematic relationship between the variable lah. Okay, so we will end up with the model. Okay, so why still the dependent variable notation that we use for the dependent variable still the y. And then we have the x as an independent variable or the explanatory variable, another term that we use to represent the independent variable. Okay, so for the economic model here represented by expected value. Okay, I think you have been well known with the expected value when you discuss the mathematical stat. Okay, so the econometric here is a combination of that lah. Okay, kita ada juga ada mathematical stack kat sini the econometric here. So we have the expected value, okay, y on x lah. Okay, so y depends on x, so we have beta 1 plus beta 2x, so there is no beta node. Okay, kalau you ingat bila when you discuss the applied statistic, you have general model is y beta node plus beta 1x. Okay, So notation that we use here for the intercept is a beta node, for the slope is a beta 1. Okay, but for the economic model here, we change a bit lah. Okay, so you have here beta 1 and then beta 2. Okay, so beta 1 still the intercept, the difference is the notation only, and then beta 2 is the slope of the regression function. Okay, and then beta 2 describe the average change in y for each unit change in x. Okay, so that's a slope lah. Okay, so by using slope we can explain. Okay, the average change in y for each unit change in x. So kenapa kita pakai average? Because of the model that we have here based on the expected value. Okay, based on the expected value. Okay, so later data, okay, later we discuss based on the data lah. Okay, so we have the example 2.1 here. Okay, so study the relationship between the household income and expenditure on the food. Okay, so be in mind that all the data that we need to use in this course must be related to the economic data lah. It must be the economic data. Okay, so kita tak boleh, sorry, kita tak boleh nak pakai another area of data lah, for example the biology ke apa, tak, bukan tak boleh, because of kita nak explain based on the economic. Okay, so that's why it must be economic lah. So kita tak boleh lah, tak boleh pakai another area of data. So the Y here is a weekly food expenditure per person, and then the X is a weekly household income. Okay, so the economic theory that we have, okay, the average weekly per person household expenditure on the food depends on the household income. Okay, so basically those are the interpretation that we write lah when we discuss the applied statistic long time ago. Okay, you took your applied statistic during the semester 2. Okay, so why average? Because we have here the expected okay, the expected value here, or is a mu lah. So y depends on x. Okay, so the economic model that we have here, beta 1 plus beta 2. So the conditional mean, okay, the EY on X is called a simple regression function lah, okay, because of we have a single independent variable, okay, with the single dependent variable. Okay, so beta 1 is the mean per person, okay, weekly household expenditure on the food, okay, by household with the no weekly income. Okay, why we said no weekly income? Okay, it is when we interpret the beta 1. Okay, when we interpret the beta 1, we let x equal to 0 lah. Okay, that's the yeah. Okay, so similar when we did the applied statistic. Okay, with no weekly income. Meanwhile, the beta 2 is the change in the conditional mean given a RM1 change in weekly income. So how much the Y change when X change? Okay, so RM1 depends on the unit that you have. In this case, I think RM100 change. Should be 100, yeah. Okay, 100 change in weekly income. Okay, so the regression function is the foundation of the economic model. So the regression that we use here is a simple regression function. Okay. So actually kita follow the methodology here, okay, that we discussed last week. Okay, statement of the economic theory. So we do have the statement here. Okay, the economic theory, the average weekly, okay, per person household expenditure on the food depends on household income. So it means that when we analyze our data, you have to start with the economic theory lah. Okay, you have to start with the economic theory. Okay, so certification on the mathematical model. Okay, what function that we want to use. Okay, specific on the econometric model. So we will see the model after this, and then we obtain the data. Okay, okay, we obtain our data and then estimate our econometric model. Okay, so we define our model here. Okay, define model here. Okay, based on the mathematical that we have, based on the function that we have. Okay, we define model here. So kalau you punya mathematical model here is a logistic regression, okay, so lain lah kita punya model kat sini. Okay, so based on the economic theory, okay, when we write the statement of the economic theory, we have single independent variable with the single dependent variable. That's why we come up with the simple regression function. Okay, and then based on that, you can define your general model first. Okay, so here we define the general. Okay, we define the general model first based on the function that we have. Okay, and then we have our data, and then we estimate the econometric model. Okay, we estimate the econometric. What we have here is a general model, and then when we have data, then we can estimate lah. Okay, the econometric model. Okay, so how to estimate depends on the mathematical model that you have, depend on the question that you have. Okay, okay. So in our case, for the simple linear regression, okay, kita akan menggunakan least square method lah. Okay, least square method. This is the common method for the simple linear. Okay, least square method. Okay. Okay, common method for the simple linear regression. Okay, so there's no manual calculation involved for this case lah untuk estimate because it will be abandoned in the coding lah. So untuk chapter ni saya pakaikan Microsoft Excel sahaja, but later on if you want to use the R programming tak ada masalah. At the end of the chapter memang saya ada letak the code lah untuk kalau you nak pakai the R programming. Okay, so kita akan dapat output yang sama. Okay, because of this method, we can use the Microsoft Excel. That's why I go to the Microsoft Excel first lah. Okay. Later on when we discuss the logistic, so logistic memang tak boleh pakai Excel lah. So that one, is compulsory to use the R programming. But for the simple linear and multiple, I plan for Microsoft Excel only lah. Okay. But you can always use the R programming. Okay. There's no restriction on that lah. Okay. So after we estimate the model, then there's something that we need to interpret dulu lah. We can interpret the beta 1, we can interpret the beta 2. Okay, we can plot the scatter plot because of this is two variables, and then we can interpret our correlation. Okay, all those common thing. Okay, for the simple linear regression. Okay, and then hypothesis testing, and then forecasting or prediction. Okay. For our case is a for our case is a prediction. Okay, because simple linear regression and also the multiple linear regression letter is kita ada limitation on that lah. So it is up to the prediction only, easily. Okay, unless kalau kita buat time series letter, it is more to the forecasting lah. Okay, so prediction and forecasting, both memang kita predict the value, tapi prediction is more to the kita panggil short term prediction, and forecasting is more to the long term prediction lah. Okay, and then use of the model for the policy purpose lah. So this one, something that we need to interpret in business mind. Okay, because we are using economic data. Okay, so we need to interpret in business mind. So kalau you ada this model, okay, and then you ada this kind of relationship, okay, what happened, okay, in business. Okay, for this case, it is about the food expenditure. So maybe let's say that the policy maker, let's say that the businessman want to open another store on the food, so dia boleh tengok lah. Okay, kalau kita punya relationship here increase, then dia boleh expect. Okay, kalau dia nak buka kat mana and so on lah. Okay, in term of the business. Okay. So this is just an illustration on the PDF. Okay, probability density function of the food expenditure at the two level of income lah. Okay, because we have here expected conditional mean here. Okay, so the econometric model. Okay, okay. So econometric models study relationship between variables to describe the average of the economic behavior. Okay, actions take on the dependent variable and its random error. Okay, so when we write the general model, okay, it is a model that consists of systematic component, okay, structure and predicted part. That's your beta 1 and beta 2 lah. Okay, and then the random error component. Okay, so that's why you have this. Okay, so your y here is a expected value just now, or the conditional mean just now, plus the kita panggil apa ni, e. Okay, plus the e represent the random error component. That's why you have this beta 1 plus beta 2x plus e. So similar when we discuss the applied statistics, similar. Okay, the general model is a beta naught plus beta 1x plus epsilon lah. Okay, epsilon represent the error. Okay, so that's why we need to estimate. Okay. Okay, so the random error represent all the factors affecting y other than x. So another factor. This factor cause observation y to show y differ from the mean value. Okay, in economic model, we want to include all the important relevant variables in the model. Okay, so the error term act as a storage bin lah. Okay, for the unobservable and unimportant factors that affecting the y. Okay, that's why we have the error term here. Okay, represent another factor that affect the x. Okay, but when we estimate, dia akan hilang lah the error kat situ. Okay, but later, okay, when we have estimated model, is actually you can calculate you punya error kat situ. Okay, the error kat situ kita panggil dia sebagai residual later. Okay, when we have the estimated model, then we can calculate our residual. Okay, because of the general model, we have this. Okay, when we estimate, then you will have the y cap, beta cap plus beta 1 cap. Okay, then we can use this. Okay, and then we can use the estimated value. Okay, bila estimated value tolak y here, then you will get your error lah. So error here, we call it as a residual. Here residual or error component, similar thing. So in order to make the econometric model complete, so there are assumptions on the model that must be satisfied. So this assumption is actually we will discuss in detail when we go to the chapter 4. Okay, evaluation of the model, if I'm not mistaken lah, the title. Okay, but for the meantime here, we do not test for this assumption. Okay, but you have to know that we have 6 assumptions. Okay, for this econometric model. Okay, the simple linear econometric model. Okay, so the first assumption, the value of y for each of x is this one lah. So you follow the general model. Okay, and then kita punya expected value of the random error equal to 0 because we need our random term is normally distributed. Okay, that's why 0, mean equal to 0. Okay. And then the variance of the random error is equal to the sigma square. Okay, and the covariance, okay, between the EI, EJ equal to 0. Okay, covariance, remember that is a variance between the variable lah. Okay. And then the variable x is not random and take at least two different value, and the random error, the random term is normally distributed. That's why we need the expected value here equal to 0. Okay, because we need to make sure that the random term is normally distributed lah. Okay, so the assumption will be detailed out when we discuss the chapter 4 later. Okay, for the meantime, we don't have to test for the assumption lah. Okay. Okay, so an econometric analysis can provide answer to the some important question, which is provide valuable information to the decision maker. Okay, so that's why when we go to the flow chart just now, the last one is for the policy maker lah untuk buat decision. Okay, for example, we continue from the example 2.1 just now. Okay, relationship between the household income and expenditure on the food. Okay, so if the weekly goes up by one RM 100, how much will the average weekly food expenditure rise? Okay, so those are the things that we can get from the analysis lah. Okay. Or could the weekly food expenditure fall as income arise? Okay. So it means that this question, okay, it can be answered by the type of the relationship that we have. Okay, whether we have a positive relationship or whether we have a negative relationship. Okay, if you have positive relationship, so means that if the income increase, the expenditure also increase lah. So yang kita belajar sebelum ni dalam applied statistic is a straightforward, whether you have positive or negative relationship like that. Okay, when we have the R, for example, the quotient coefficient, then bila kita interpret, so it more to straightforward lah, positive and negative. Okay, but when we discuss the econometric here, we interpret based on the data that we have. Okay, so the first question here is actually kita nak tahu je, okay, the relationship tu positive or negative. It can be answered by that lah. Okay, so how much would we predict the weekly per person expenditure, okay, on food to be for the household with an income of 1,000 per week? So predict means that we need the model. Okay, we need a model lah. Okay, because we predict. So it means that kita nak tahu Y, okay, kalau kita punya X, RM 1,000. So we interpret based on the data. Okay. Or maybe the question is okay. So this one also. How much will average weekly food expenditure rise? Okay. So it means that this can be answered based on your beta one. How much it change? Okay. Kalau weekly goes up by 100, so it can be answered by beta one. Okay, all those things lah. So we interpret based on the data that we have. Okay. Okay, from the business perspective, if we are managers of a supermarket chain, okay, the restaurant or health food, we must consider the long-term plans. If the economic forecaster predict that local income will increase over the next few years, then we must decide whether or how much to expand the facility lah to serve the customer. Okay, kalau dia meningkat, kalau kita dah tahu dah. Okay, let's say that we have positive relationship. So income meningkat, income increase, then the expenditure will be increased. Okay, so kita boleh decide lah, okay, how much that we need to expand the facility to serve the customer. Because kita panggil apa, demands on the food will be increased. Okay, when income increase, then the demand ataupun the expenditure will increase also lah. Okay, so means that we need more store or more facility to serve the customer. or we plan to open franchise in high income or low income neighborhood. Okay, because what we have here, the household income, so we can decide based on that. Okay. Then the forecast of the expenditure on food per person give an indication on how large the store those areas should be lah. Okay, for the high income and low income. Okay, so kita boleh tengok lah. Okay, income yang low income, so macam mana dia punya expenditure, the data tu macam mana. And then kalau high income, dia macam mana dia punya expenditure. Okay, so this is based on the business perspective because we are talking about the economic data. Okay, so I mean the theory tu you dah tahu, cuma cara kita nak explain based on the data lah. Okay, and then we go to estimating a simple regression. Okay, ataupun kita nak estimate kita punya econometric model. Okay, so because of we are using the simple linear function. Okay, so the common method that we use is a least square principle ataupun least square method lah. Okay, so kalau kita pakaikan Microsoft Excel, okay, ataupun doesn't matter that use the Microsoft Excel ataupun R, this method embedded in there lah. Okay, dah. Memang the common method is a least square method. So tak kisah you pakai Microsoft Excel ataupun R, this is the method that the software use, embedded in the software. Okay. Okay, when we estimate, okay, when we estimate the econometric model, then you will get this model. So it is a Y with the cap. And then the residual, the error term, okay, it will be Y, it will be the Y minus the Y cap lah. Okay, oh tadi saya terbalik. So it should be the Y minus Y cap. Then you will get your residual value ataupun the error term. Okay, the error value. Okay, so this is the formula behind that lah. Okay, the formula behind the least square method. Okay. 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 So we have here our estimated model is a Y cap. Beta 1, there's a cap here. Oh, did that the cap, sorry. Beta 1, beta 2, sorry, B1, B2, the X lah. Okay, but the Y will be with the cap. Okay. So the properties of the simple linear regression equation. Okay. So in our case, is our econometric model lah, because we are using here a simple linear function to estimate our econometric model. Okay. So it is a line that best represent the data of the scatter plot that pass through the S bar and Y bar. Okay. So this is, ini memang kita ambil pada belas statistik je. If you see, remember. Okay. A line that minimize the sum square difference between the observed value, your Y, and predicted value. Okay, you can see from the here. Okay, when we have scatter plot, okay, okay, minimize the square difference, okay, between the general and also the predicted value here. Okay, so kalau kita punya value close and then we have best fitted line lah. Okay, best fitted line. Okay, kalau dia far and then not the best fit line lah. Okay, consider a good approximation of the true relationship between the two variables. Okay, a linear line with the regression constant, which is your B1. Okay, and it still intercept lah. Okay, and a linear line with the regression coefficient is your B1, or the slope of the regression line. Okay. So we can use that model to predict the value of the variable given a value of other variable. So whether you predict the Y, okay, given X equal to something, or you predict the X given Y equal to something. Okay, both way lah. Okay, and then we have the interpolation and extrapolation. Okay, when we do the prediction, it will be two type of prediction here. Any questions so far? Soalan ke? Is it clear? Yeah, is it okay? Okay. Okay, saya ambil nafas dulu. Okay. Okay, so when we do the prediction based on the simple linear model here ataupun the econometric model based on the simple linear function, susah nak cakap tu panjang. Okay, so saya tak nak you keliru. It is econometric model based on simple linear function. Okay, because we have single independent variable with the dependent variable. Okay, so when we do the prediction here, it will be two types of prediction. Okay, it will be either interpolation or extrapolation. Okay, so interpolation, it means that we predict something that in range of value, sorry, in range of data set. Okay, ni just recall back lah from the applied statistic. Predict value in range of data set. Okay, data set means that the data set that we use in order to develop our model. Okay, extrapolation predict value outside of range of data set lah. Okay, outside the range of the data set. So we need to be careful with the extrapolation. Okay, it might be the value that you predict is not really accurate lah. It's not accurate. Okay, because of you predict something that far from the range of the data set. Okay, so that's why I said kalau kita nak predict something, it's better we use forecasting. Okay, it's better we use our forecasting. Okay, because forecasting is a long term punya prediction. Okay, prediction ni is a short term punya prediction. Okay. Okay. So you can open your Microsoft Excel. Okay. So I already provide you with the data lah. Okay, in Microsoft Excel. So you just open that data. Okay, that Microsoft Excel. Okay. So for the simple linear regression here, as I said, I've used Microsoft Excel only, but there's no limitation for you to use R programming, tak ada masalah. Okay, for the lab report letter, saya tak tahu lagi. I mean, saya tak ada dalam email lagi, the lab report tu soalan macam mana. If the question, the lab report one is about the chapter 2, if I'm not mistaken, then it's up to you. Okay, it's up to you. You boleh je pakai R programming, tak ada masalah. Kita akan dapat output yang sama selagi datanya sama lah. Okay. Okay. So dalam yang punya Microsoft Excel, you ada function data. Okay. Under tab data, you will have data analysis. Okay. And then click on that data analysis, then you will get, I show you here. Okay, stop sharing here. Okay, I show my screen here. Sekejap Okay, I think you know how to do, but just recall back lah. Okay. Mana ni? Okay. Can you see this screen? My screen now? Aduh, kat mana ni? Aduh, sekejap. Sekejap Aduh. Sekejap. Okay. Can you see my screen now? Boleh? Okay, Okay, thank you. Okay, so example 2.1, you have this. Okay, expenditure, your Y, and weekly income is your X. Okay, so you boleh buat juga dekat you punya ni Excel. Okay, when you go to the tab data, okay, kalau you masih menggunakan pakai laptop daripada zaman applied statistik, you will have your data analysis here lah. Okay, kalau you dah tak, I mean you change your laptop, okay, it's a new laptop, then you have to add your data analysis. Okay, so kalau tak ada data analysis under tab data, so you go to the file here, and then you go to the options, and then you go to the add-ins. Sekejap laptop saya ni dia sikit puasa. Tak keluar ni. Okay, and then you have here finish, and then click go, and then you have this. Okay, you have this figure, and then you tick on the analysis toolpath, and then you will have your data analysis under the tab data, and then okay. Okay, so after you have your data analysis here, okay, click on the data analysis, then you have your regression here. So dia ada banyak lah, regression, correlation, okay. So regression, what we did is a regression. So same to the multiple linear regression letter lah, the chapter 3. Okay, and then you just insert you punya Y. So Y is this one, like, and then X this one. Okay, and then because of we include the label, make sure that you tick label here, and then output range, let's say that somewhere here. Okay, and then okay. So you have your output lah here. Okay. So you ada you punya art, so kita boleh interpret juga kita punya art. Okay, so how to interpret correlation coefficient? Same as applied statistic lah. Same as this we discuss in multivariate also. Okay. And then untuk model, kita pakai the last table here, the coefficient table. Okay, kita panggil dia as a coefficient table. Okay, so intercept here, that's your beta, sorry, it's not beta, B1. And then the slope here, that's your B2. Okay, B1, B2 here. And then we have the correlation coefficient here. Okay, also we can use to discuss relationship. Okay, so the R here depends on the sign from B1. Okay, sorry, B2. Because of the SL, itu satu kelemahan SL lah. Okay, so dia tak boleh nak distinguish, tak boleh nak tunjuk kat sini positif ke negatif. So kita kena tengok daripada B2, the slope. Kalau slope kalau negatif, then it will be sign negative lah. Okay, similar to the B1, the intercept. Okay, so you punya art follow the sign of B2. So kalau B2 here negative, then here should be negative lah. We read as a negative value. So in this case, positive, then we read as a positive, the correction coefficient. Okay. Any question on the SL? Okay. And then saya tunjuk terus kalau you nak sketch the scatter plot. Okay. So kalau you pakai R, you you write the coding, then you will get your scatter plot lah. So kalau Excel ni, it will be a bit manual lah, you have to do, okay, one by one. Okay, so again, it's up to you. Okay, boleh je nak pakai art programming, tak ada masalah Okay, so untuk scatter plot, you go to the insert here. Okay, I think you know, but we just recall back what we have discussed in applied statistics. And then you click on here, the chart here, scatter. Okay, so you will have this. Okay, you akan ada this. So right click on the box here, then you have select data. Okay, So select data, then you go to the add. Series name, for example, here is a scatter. Okay, scatter diagram. Okay, X value. So this is your X. Okay, jangan masuk label lah. Dia tak boleh baca pula. Y value, this is your Y. Exclude the label nanti your punya Excel tak boleh baca. And then okay, and then okay. Yeah? Then you will have this lah. So bolehlah remove the line. So nampak. Okay. Then you will have this scatter plot. Okay. So kalau nak cantikkan, I mean nak tambah dia punya chart title, kalau you pakai art, dia akan terus keluar lah you punya chart title. You punya apa tu, the title of your X, your Y lah. Okay, you go to the plus here, and then you have exist title. So, okay, boleh edit lah kat sini. Title dia apa? So Y is a expenditure, X is a income. Okay, so this is how we do the scatter plot lah by using the Microsoft Excel. Any question on the Microsoft Excel before we go to the interpretation? Soalan? No question Okay, jap. Jap Sekejap, I need to check on something. Okay. Okay. No question on Microsoft Excel. So I stop sharing here. Then we back to the note lah. Okay. Okay. Okay, so the example, example 2.1 just now. Okay. Okay, but is it similar example Same example when we discuss the economic theory. Okay, so this is the scatter plot. Okay, so based on the scatter plot, okay, you can interpret your scatter plot. Okay, so when you discuss applied statistik dulu, dia ada 4 pattern of the data that we can identify based on the scatter plot. Okay, so satu is a linear, positive trend or positive relationship. Dua, you can have the negative trend. Third, no trend. Okay, it means that the relationship is very low lah. Okay, when no trend, it means that your data points scatter. Okay, from each other. So kalau the up not really zero. Okay, but it will be very low lah. Okay, and the fourth one is a curvilinear lah. Okay, curvilinear here is for the non-linear. So kalau you dapat curvilinear, it means that you have non-linear data lah. Okay, so in this case, we can see that increasing data point. So we can write here the scatter diagram represent graphically, okay, the positive linear relationship between the weekly food expenditure and the weekly household income. Okay, because the data is a weekly data. That's why we have to mention the weekly. Okay. So graphical is a positive linear. Okay. So to confirm how much that related to each other, then we can go to the correlation coefficient. Okay. Okay. So this is the output just now. Okay. Okay. For the fitted model, okay, we are using the last table, coefficient table. Okay. So as I mentioned, this is your B1 and this is your B2. Okay. So you will have this fitted model. Okay. So this is your fitted econometric model. Okay. So how do we interpret the B1 and B2? Okay. So basically, yeah, memang similar dengan applied statistic, but maybe the way, okay, we have to interpret by using is based on the data lah. Okay. So a household with the zero income is expected to spend, okay. So because of we have B1 83.141, and then the unit use is a RM. Okay, so expected to spend RM 83.42 per week on food. Okay, so zero income. Okay, because when we interpret the intercept, okay, X must be zero. Okay, we let X equal to zero when we interpret the intercept. Okay, that's why zero income. Okay, and then we have the beta 2, the slope. Okay, 10.2096, and it's a positive. Okay, so slope akan konsisten dengan you punya scatter diagram lah. Okay, so kalau you dapat positif, then it should be positive slope. Okay, and it will be consistent also to the correlation coefficient. Okay, so if weekly household income goes up by RM100, because the unit used is a by RM100. Okay, the data collect based on RM100. Okay, so goes up or increase lah. Okay, because of we have positive. Okay, kalau negative, then must be decrease. Okay, so decrease here if negative value. Okay, expected weekly, so this is your X. Expected weekly expenditure on food will increase by approximately RM 10.21 based on your B1 here. Okay. Sorry, it's not here actually, positive negative ni kat sini, sorry. Kat sini memang always increase kat sini, sorry. Increase because of we have positive value. Okay, so kalau you ada negative value, then here will be decrease. Okay, so based on the business perspective, Okay, what we can write here. Okay, for example, a supermarket executive with information on likely change in the income and the number of household in the area could estimate that will sell RM 10 ringgit lah, more typical household per week. Okay, for every RM 100 increase in income. Okay, setiap 100 increase, then kita expect kita boleh jual RM 10 lah on the food. Okay. So this is a valuable information for the long run planning. So itu kalau 100, kalau we have 1,000 increase, then here we can sell more lah the product. Macam tu. Okay, we can sell more the product. Okay, so kalau kita punya beta 1, sorry, B2 kita negatif, it means that rugi lah, kita akan rugi. Okay, kalau sini negatif, so macam mana nak baca, macam mana nak interpret here? So it means that the supermarket will lost lah. Okay, we lost RM 10 ringgit for each RM 100 income increase. Okay, so that's how we interpret based on the business. Okay, kalau negatif, then it means that kita akan rugi lah. Okay, we lost the money lah. So kita akan lost RM 10 ringgit for each 100 increase in income. Okay, so kalau kita ada 1,000 kenaikan, jadi lagi banyak rugilah. So actually it's not logic lah, takkan lagi banyak duit lagi tak makan. Tapi this is what based on the data lah. Okay. Okay, so this is the line lah that represent the model that we have. Okay. And the line here, okay, it must go through the X bar and Y bar. So this is your X bar and Y bar. Okay, you mesti masih passing through the X bar and Y bar. So kalau kita buat by using, kalau you buat manual, then you have to make sure that you punya line tu sentuh dekat X bar and Y bar lah. Okay, dia mesti point melalui point X bar and Y bar. Okay, tapi kalau kita dah buat in Excel dalam R, itu dah embedded kat situ. The line must be passing through the S bar and Y bar. Okay. So what is elasticity? Okay, 2.3. So elasticity in economic measure the responsiveness of one variable, okay, to change in another, such as price or income lah. Okay, so how the Y change in X. Okay. Okay, how Y change in another lah. Okay, how Y change in X. Okay. Yeah. So the formula that we use, this one you have to calculate by your own. Kita tak boleh baca daripada output Microsoft Excel. This one is a manual calculation lah. Okay, it's a manual calculation. Okay, so the formula that we use, okay, so the unit of the elasticity is a percentage. Okay, that's why we have this. Okay, so the notation that we use is a epsilon. Okay, epsilon here. Okay, notation that we use for the elasticity. Okay, so kita nak tengok how much the Y change in X lah. Okay, so the unit is percentage. Okay, percentage change in Y. So that's why kita panggil apa ni. This is a notation to show that we have the changes lah. It's actually, I forget the name of this notation. Okay, but it shows that we have the changes. Okay, so if the elasticity is less than 1%, essentially, okay, we would classify the data of Y as a necessity rather than luxury. So kita boleh tengok the Y here is a necessity or is a luxury. Okay, if less than 1%, then it's a necessity. If greater than 1 is a luxury lah. Okay, we can classify our Y. Okay. Okay, so the elasticity of the mean Y to X, so dia adalah mean of Y to the X, so that's why we have here this notation. Okay, so in a linear model, the elasticity is different on each point upon the regression line, and most commonly the elasticity is calculated at the point of bits. Means that at the point of S bar and Y bar. So because of that, okay, from here, okay, we have this, formula. Okay, so the N formula for the elasticity, estimated elasticity is this one lah. So this is the formula that we're going to use. Okay, so we are using the B2. Okay, the changes. Okay, the changes. This one is it is coming from here. Okay, the changes of Y on X. So that's your B2, the slope. Okay, and then it calculate on the point of B's, S bar and Y bar. So that's why we have this formula. Okay, so this is the final formula lah that we use to calculate for the elasticity. Okay, so kita nak measure how change the Y, okay, on the X. The expenditure elasticity is a useful way to characterize the responsiveness of the customer expenditure to change in income. So this is by using the previous example. Okay, so kita write it as a expenditure necessity lah. Okay, because kita nak tengok the Y. Okay, so you have your S bar and Y bar. This one you have to calculate. Okay, kalau kita menggunakan Excel, then we must be manual lah kat situ. Okay, S bar and Y bar. And then we have our fitted model because we need the B2 here. Okay, so the estimated expenditure necessity. So we have the B2. Okay, we have the S bar here, and then we have the Y bar here. So you will get 0.7058%. Okay, the unit used is percentage. Okay, so the interpretation, we estimate that a 1% increase in weekly household income will lead on average, to a 0.7058% increase in weekly household expenditure on food. Okay. So kalau you punya B2 ni negatif, then you will get negative value lah. So here akan jadi decrease. Akan jadi, macam mana jadi decrease eh? Kan decrease lah. Okay. Kalau B2U negative. Okay. So since the estimated expenditure necessity is less than 1, then we would classify the food as a necessity lah rather than luxury. Okay, because of the estimated expenditure necessity is less than 1. So we can classify Y here as a necessity, not the luxury lah. Okay, so that's how we calculate. We interpret and also calculate the elasticity. Okay. Any question? Soalan? Okay. Thank you. Okay. Thank you for the response. Okay. So, this is the example that I add. Okay. I think it is related to the economic lah because it's a insurance is a part of the economic. Okay. So, but later on, I think I should have a better data lah. Okay. Tapi limited time, then this is a data that. So just a simple data. Okay. So, okay, so it is about the alias sell the life insurance, okay, for the Prudence Insurance Company. Okay, so she sell the insurance by making visit to her client homes. So Alia believes that the number of sales depends on the number of visit made. Okay, for the past several years, she has kept a careful record, okay, of the number of visits and the number of people who buy insurance each week. So it's a weekly data. Again, it's a weekly data. Okay, so we have here weekly data. For the random sample of 10 weeks, the data is given in table 1. So weekly data, this is number of visits. So number of sale, depends on the number of visit. So the number of sale here interpret as a number of people who buy the insurance lah. Okay. So macam mana they collect the data on the number of sales. So they collect the data of number of people who buy the insurance to represent of sale lah. Okay, to represent of sale. So semakin ramai yang beli means that sale banyak lah. Okay, so number of sale meningkat. So it means that so here represent the sale lah. Okay, the sale. So sale depends on visit. So this is your X, this is your Y. Okay. Okay, we go one by one, starting from the economic theory. Okay, so sama macam tadi, but kita sesuaikan dengan data yang kita ada lah. Okay. So the economic theory is the average weekly of the number of people who buy insurance depends on the number of visit made. Okay, so sama macam tadi, but kita sesuaikan dengan data that we have. Okay. So it's still regression, simple regression function because of we have single independent variable. Okay. And then the econometric model, because of simple regression function, then you will have this model. Okay, just a general model. Okay. Yeah. Okay, and then we go to estimating the economic model. Okay, so you can sketch your scatter diagram. Okay, you can try after this. You boleh key in the data first and then play around lah with that. Okay, so we have the scatter diagram here, and then you can comment on the scatter diagram. Okay, so scatter diagram represent positive linear relationship lah. Okay, between the weekly number of people who buy the insurance and the weekly number of visit made. Okay, this is the output. Okay, and then we have our fitted model based on the coefficient table. Okay, so this is your B1 and this is your B2. Okay, so how do we interpret here B1? Okay, number of people who buy insurance with zero number of visit made is expected approximately 2 people per week. So why I put approximately here, because kita bagi apa? Round up lah. Okay, because kita adalah discrete number. Okay, so you have 1 point something, then you just round up to the 2. Okay, so approximately 2 people per week. So tak ada 1.15 people, tak ada. Okay, because we have discrete data. Okay, and then we have the B2, 0.3062. Okay, that's your slope. If the weekly number of visit goes up by 1 visit, because the unit is berapa kali dia pergi visit kan, that's the unit lah. Okay, by 1 visit expected, weekly number of people who buy insurance will increase by approximately 1%. Okay, because we have 0.3 something. So we just round up to 1 lah. Okay, because we have again discrete data. Okay. So the information that you can obtain should be an insurance agent with information. Okay. With this information, could estimate that he or she will sell. Okay, we sell 1 insurance per week lah for every 1 number of visit increase. Okay, so kalau it should be like, kalau dia pergi 2 kali, dan 2 insurance lah yang boleh jual. Okay, so and also the insurance company also can invest on the home visiting to increase the sale. Okay, so those are the interpretation that we can write on the business perspective. Okay. So on the elasticity, okay, so it is about the insurance sale as elasticity. Okay, so it is about how much the Y change on X. Okay, so we have the fitted model, and then we have the X bar and Y bar here. You have to calculate by your own. This one, okay, you can use your Microsoft Excel. Okay, and then calculate for the elasticity. Okay, so by using the formula before, okay, epsilon predicted, okay, then you will get 0.8044%. So this is percent. Okay, so for the interpretation, we estimate that one increase in weekly number of visit will lead, okay, to the 0.8044% increase in weekly number of people who buy the insurance lah. Okay, and then because of it is less than 1%, then we could classify the insurance as a necessity lah rather than a luxury. So it's actually true lah, okay, based on the current I mean based on kita punya pemerhatian, insurance is a necessity lah actually. It's not the luxury. Everybody should have their own insurance lah. Okay, for ni lah, if anything happen. Okay. Any question? Senyap ke? Soalan tak? Okay, you boleh key in the data and then try to get your own output. Okay. Saya tak ada exercise kat sini. I think nanti I add exercise later lah when we discuss the 2.4 and 2.5 together. So kita boleh buat from the beginning until the end lah, until the prediction. Okay, so I will add the exercise later. Any question? Soalan? Ada soalan ke anak-anak? Okay, kalau tak ada soalan, I think that's all for today. Okay, if there's no question, so that's all for today. Selamat Hari Raya. Okay, kita akan berhari raya the end of this week, insyaAllah. Okay, so selamat Hari Raya, and then kita jumpa on week 4 here lah. Okay, in class. So don't forget that I changed the timetable. So the class now is on Tuesday and also the Thursday. Okay, so I'm really sorry on the changes because of, yeah, I cannot manage lah. If our class on Monday, I cannot manage on in term of the preparation. Okay, so that's why I have to change the timetable lah. Okay, so selamat Hari Raya, take care yourself. Kita jumpa in class on week 4 later. Thank you.
Thank you, Doktor.
Okay, baru dia suara.